Hello, everyone, and thank you for joining the second event in our AI webinar series, which is part of the AI at Smith initiative. And just like last time, we are very interested in your comments and questions on this topic. So at any time during the program, please use the Q&A feature, and we will answer your questions at the end of the presentation. Before we get started, just a quick reminder that this webinar will be recorded and made available to the community on our website, so please keep that in mind. Now I'd like to introduce myself. My name is Clayton Ritchie, and I am a program manager here at the University of Maryland, Robert H. Smith School of Business in the Office of Executive Education. Our mission here at Smith Executive Education is to share the great work that our professors are doing with the community, so we are really excited that you are all here with us. Our topic for today is AI design experiments, how to orchestrate human and AI ensembles. And our speakers for today are Suresh Acharya and Balaji Padmanabhan. Now, I'd like to tell you a little bit about Suresh and Balaji by way of introduction before we get into the presentation. Suresh is a professor of practice here at the Smith School and also the academic director of our MS in Business Analytics. You can see his areas of interest and contact information up here on the screen, and if you'd like to reach out to him, please feel free to do so. Also with us today is Balaji Padmanabhan, who is a professor here at the Smith School. He is an expert in computer science, data science, AI, and machine learning. You can see his email address here up on the screen, and if you'd like to reach out to him, you can do so as well. Now, I'd like to turn it over to Suresh, who will kick us off with a recap of our last discussion and explain how it's related to today's topic. Suresh?
Clayton, thank you. Thank you very much, and welcome everyone to this ongoing webinar series that is part of the Smith AI initiative. The last time we met, we got a glimpse into the wonderful world of generative AI. We talked about large language models, and the title was To ChatGPT or Not to ChatGPT, where we got to learn about what technologies have come together in order to make a generative AI a reality. Next. When Professor KZ kicked us off, he made us aware by quoting Andrew Ng, one of the foremost thinkers in the space of AI and ML, that AI is essentially a collection of tools. They're actually interrelated. The wonderful world of supervised learning, unsupervised learning, the notion of having rewards to enable reinforcement learning. And of course, a lot of these are interrelated, and we got a glimpse into what generative AI was. Next. The way Professor KZ walked us through it was to say, look, generative AI has already been here for some time. When we write emails in Gmail or otherwise, how is Google already reading our minds as to what the next set of words or phrases might be? And so while we took that for granted, that it had just learned, generative AI was already here. And so Professor KZ talked about this notion on the right there, that generative AI is built by using supervised learning in a repeated manner, so that it knows what is expected in the next series of texts. So I just wanted to recap what we've done, because a lot of what we're going to talk about today does touch on topics that we introduced then. The notion of hallucination. Why are these models absolutely not perfect all the time? But also we got into security and governance and some of these other topics that Professor Padmanabhan is going to get to today. So I wanted to welcome everyone to this ongoing series. Thank you for being here. Back to you, Clayton.
Thank you, Suresh. Now I want to launch our first poll. So you will see a question on your screen about trust and artificial intelligence. We're very interested to know your thoughts on this. So please read the question, choose the answer you think is best. I'll give you a minute to read that question. Think about what is the best answer for you. Oh, great. We're already seeing some responses coming in here. This is great. I can see there is a very popular choice here. I'll give everyone a few seconds to make their final choice if you haven't already, and then we're going to end the poll and share the results so you can all see on your screen. Okay, I'm going to end the poll now and share the results. As you can see, most of you chose humans taking the lead, with AI playing a supporting role as the most trustworthy. And some of you thought that AI taking the lead with humans playing a supporting role would also be trustworthy, but I can see there is definitely a strong winner here for our attendees. Okay, everyone, I'm gonna stop sharing now. You can close the window if it doesn't close on its own, and we're gonna continue with our presentation.
All right. So thank you, Clayton, and thank you, Suresh. Thanks, everyone, for joining us this morning, afternoon, or evening, whatever time it is in your time zone. So my name is Balaji Padmanabhan. I'm a professor at the University of Maryland, and I wanted to give you a brief introduction of my background so that you get a sense of where I'm coming to a lot of this from. Also, the content itself in this webinar has been designed for a broad audience, as expected, right? Because the people who join this tend to be professionals, tech experts, researchers across the board, and so this is kept, broad from that perspective. Now, my background itself was in computer science, and my PhD was in information systems in a business school about 25 years back, in doing machine learning for business applications. And for about 25 years, I've been doing more or less the same thing, but in academia. And my work tends to be a little more on the technical side, but mostly motivated by business applications. One of the really nice things in the last 20 years or so, which I've always enjoyed talking to people in industry, and I know that today most of you come from different companies and have very different backgrounds in traditional academics. I've always learned a lot from my friends in industry who are doing these things. But given that I've enjoyed, staying in touch with many of them, I've also paid attention to some of the problems. I've worked with many companies in the last, 2 decades or so. But in the last year in particular, right, some of the conversations I've had with very large companies in very different sectors, and healthcare, financial services, building materials. These are billion-dollar firms, and I talk about these things with some of them in terms of the challenges that they see. Now, AI has obviously been around for a long time. And so the content of this webinar itself is, in a sense, inspired by some of the worries or frustrations I've heard from some of these conversations. So now the title itself is AI Design Experiments, and it does, talk about the need to think about experiments in terms of how we want to combine AI and humans. But I do want to stress at the outlet that this webinar is not going to have any magic solutions, right? So the goal for me, given the broad audience, is to give you enough to get you thinking about this and to understand this from my perspective, and probably pick on a few things that can then take you in a new direction yourself, right? If we can accomplish that in some way with this webinar, I think that's a success for me, right? So I do want to start with the same old context because I think it's important when we are talking about AI, what we mean by AI. Now, to me, I've been in this space now. I think if I, give myself some leeway for pulling in my even my undergrad thesis, I'd say almost 30 years. And when I've looked at AI then and even now, the theme that I feel stands out and holds over time is this focus on intelligence, right? So AI has always been about, can we build intelligent systems, right? And initially it was about building intelligence that resembles human intelligence. But over the years, and particularly recently, we've seen in many cases that it's actually gone beyond that as well, right? But the focus has always been, can you do things that demonstrate intelligence? Now, the foundational ideas behind how to do this have changed over time, right? So when we talk about what is AI, I think it's important to take this bigger perspective, but also to understand that within the field itself, the basic ideas that drove intelligence have changed, right? So years ago, it was symbolic knowledge, fuzzy logic, heuristic search algorithm. My undergrad thesis was on genetic algorithms. Subsequently, neural nets, connectionist models. In the last 10, 15 years, it's deep learning, reinforcement learning. And today we're very interested in these large scale neural net based generative models, right? Now, the reason I bring this up is that the underlying technologies have changed and may continue to change as well, right? A few years back, uh, we would not have predicted necessarily, what came about in generative AI. I think a lot of people, even in research, were very surprised, pleasantly surprised. But I think we should hold that surprise and think that, look, there could be newer things as well that come in the future. Now, that said, from a very practical point of view, at least in industry, when people think about AI, there's a lot of interest today in data-driven AI systems. And when you think of data-driven AI systems, one characterization that's been made recently has been this distinction between predictive and generative AI, where predictive AI is about data driving predictions, and generative AI, as I think Suresh briefly summarized, was that data driving more data, right? So a very simple example in the context of predictive AI, it might be things like taking an email text and then training a machine learning model to predict whether it's a spam email or not. This we have spent the last 20 years perfecting, and there are amazing models that make great predictions if given large amounts of high quality data. Generative AI, on the other hand, goes from data to more data, right? So here you have a trained generative AI model plus a context that's provided to it in the form of a prompt or a series of prompts. And the context plus the model together create new output, right? And so it's generating more data. And I think characterization has been useful. And I think let's go with that for the rest of this webinar, right? So when we think about AI here, we're thinking primarily about these two different types of AI, right? But at the same time, it's important to note that we're not only talking about generative AI, we're talking about both. So when I first suggested to Suresh and Clayton, let's do something like this, one of the one of the main drivers for me was this, as I mentioned earlier, was this frustration in industry sometimes about not getting a return on investment in some of their machine learning or AI initiatives, right? Going back 10 years, right? So some of you may be surprised saying, what is he talking about, right? And others, maybe you've experienced this pain yourself. And in the context of predictive models and making predictive models work in real life for businesses, I think we have a very good understanding now about how to do that, because this has been around for 20 years. And there's been phenomenal work in the context of using experimentation to refine predictive models so that you constantly test return on investment. And this is a phenomenal book. Ron Kohavi was one of the first in industry to build experimentation platforms online. And in the online world, this is now widely done, right? So companies know how to build, deploy, test predictive models, govern them, and the whole thing is now fairly well understood, I would say. Yet, even in the context of predictive models, from my many conversations with regular companies, what I've seen is that NFO businesses still struggle. So What is NFO? Non-fully online, right? So we cannot have a webinar without making up a new term. And so this is the new term, right? And so if you take online platforms, right, the Googles, Microsofts, the Facebooks, Amazons, and so on, they do control a fairly large part of the economy, and not just the economy, they also control a large part of our attention as people, right? And chances are most of you may also have involvement with these companies, or maybe are with some of these companies too, right? So if you're in the online space, things are a little easier. I would say a lot easier in terms of building and testing predictive models to make sure that you can get return on investment, right? And through these careful experiments, these so-called A/B tests, where you build different predictive models, take random groups, expose them to different treatments, and then with data coming in on a constant basis, you can actually tell whether one algorithm worked better than another. And how do you know that it's better? Maybe because you're selling more and so on, right? So all of these things are relatively easy to do in an online setting. Again, if you read this book, you'll know why it's not as easy as people think it is. It's a fantastic book, but I would still say relatively easy compared to what we're calling here as the non-fully online businesses. Now, I ask, so this is the should you be fired quandary. So I teach this, I've been teaching this for a long time. And when I teach predictive models in my class, I ask my students, right? So, let's say you're working for a hospital, and many of you might have heard of this 30-day readmission requirement, or rather the non-readmission requirement, that hospitals have an incentive to make sure that a patient who is leaving doesn't come back in 30 days, right? And there's reimbursement, et cetera, that might be tied to things like this. So there's been in the last, I think, many years, there's been interest in building predictive models, which will predict if a patient who's being discharged comes back in 30 days. And so what I ask my students is saying, hey, you're a data scientist, you built this model for a hospital, they are using it, they've deployed it, we roll forward 6 months, and readmission rate has increased. Should you be fired, right? Now, half of them in the class say yes, half say no. The people who say yes are the very conscientious people, I think, who take responsibility for anything and everything under the sun. They blame themselves. They say, it didn't work. It must have been me. And usually the others, out here, they say, well, I don't know what happened with it, right? We built a model, but what did the hospital do? And that's a great question, right? Because in practice, what we've seen is that this itself is non-trivial to think through. You could have a good predictive model, right? And suppose, hypothetically, right, let's say a hospital decides to act on it by saying, if my predictive model is going to predict that someone's going to get readmitted, we're going to discharge them, and then we'll start calling them at home to check on them, right? Now, that seems to be a good thing, but in practice, some of these things could also backfire in ways we least expect. A patient getting calls suddenly at home might, wonder, how bad is my situation that someone, wants to check in on me now suddenly all the time. This never happened to me. And so this could cause, panic attacks in the person going back to the hospital. Interestingly, if some of you are interested, email me. I can send you a somewhat funny study related to this as well. But the point here is that it's not just the predictive model, but how the hospital chooses to act on it that can make a difference, right? And now, on the other hand, you can think of a million other ways the hospital can build a system to act on this, right? So, for instance, instead of discharging the person, maybe you want to keep them for a few more hours, maybe an extra day, right? If the model has flagged that they are high risk of coming back. I'm not advocating for one over another here. But my point is that the success or failure of this is usually not a function of just the predictive model. It is a function of the predictive model plus the system that the hospital puts around it. You will find similar issues across the board, even in the context of predictive models for NFO firms, right? The non-fully online firms, where the process that plays out in the background around the predictive model really matters. right? So one of the most famous articles about deep learning in medicine was probably the first paper from Google DeepMind, Google's super fancy R&D group in the UK, which they subsequently bought and integrated. So the Google DeepMind had partnered with the VA, sucked in all of the VA electronic health data, and using deep learning, they had built a black box predictive model that would predict acute kidney injury in a hospital setting. And there was a paper about this just a few years ago. And this was a black box predictive model that just makes a prediction, right? A patient is in a hospital, AKI is supposed to be very dangerous. And now you have a black box model that can give you a prediction, which is right. I think this flag was 1 out of 3 times. For every time it gives you a signal, 1 out of 3 times it's likely to be right, 2 out of 3 times it's likely to be wrong. So I asked doctors, we used to run programs for doctors, and I asked a group of 20 physicians saying, when this paper came out, would you use this, right? You're physicians, you're treating people. Now you have this, AI that's giving you predictions in a inpatient setting, complicated patient case. Will you use it? It's a black box model, right? You simply cannot understand how the model works. I was surprised to find that most of the doctors said yes, that this is another signal, that they're used to processing signals, that this is another signal, right? But some of our earlier discussion applies to this case, right? When you push them a little more in terms of how they would use it, you start you start seeing the doctors come up with different ways, right? That this signal could be used in practice. The same argument applies, right? Depending on how the signal gets used in practice, it may turn out that this system is good or bad, right? And again, it goes back to the fact that it's not just the model, but the model plus what we do around it that affects goodness or badness, or however you want to think about it. All that is predictions, and the situation gets infinitely more complex for generative AI. Recently, there were companies that rolled out financial advisor tools using generative AI to their financial advisors. And their advisors now have access to this tool where they can ask questions based on a client, based on all kinds of research reports. Generative AI comes up with recommendations, with reasons for what it's recommending, and so on. Now, at the face of this sort of looks like this is similar to doctors using predictions from machine learning model, right? Because we are giving financial advisors a Gen AI tool to advise clients, more or less similar to doctors using predictions, right? Previous example. So not quite, right? There are some very important differences that actually make this even harder than what we discussed before. First, with Gen AI, this is much less understood than traditional black box predictive models, right? And it's much less understood, not because the math is difficult, right? Many times the math is difficult, but many times we don't even know what data these have been trained on. That is not public. There are companies with the name open in it that people wonder whether it's really open or not. But these are discussions we are seeing every day in the press, right? And so this is an issue. However, the second reason why these Gen AI tools tend to be even more complex is that predictions still are a finite set of things, right? Death, no death, 30-day readmission, no readmission, high risk, low risk, right? Bunch of finite classes. Gen AI, on the other hand, has infinite variety in what it can come up with. So we're not dealing with just a finite set of options here. Often we are dealing with an uncountable list of possibilities that we might see it generate. The third reason why this becomes even more complex is that predictive models typically give the same input, you would get the same predictions, right? But in generative AI, there's built-in randomness in terms of how the outputs are created. This makes it very hard to even recreate the identical situation, right? You try the identical situation, the built-in randomness can ensure that you're going to get a completely different output. So what does this mean, right? I've talked a lot here, put some of you to sleep. It's lunchtime for many of you, I think. But what does this mean? So one main takeaway for me, and this is something that I've seen again in the non-fully online settings, this is what drives frustration for a lot of regular businesses who are struggling to use AI, is that the AI models alone rarely determine success or failure in most NFO settings. And what this means is that we have to start thinking system, which is not just the AI models alone, but it's us plus AI. And that us might include processes, not might, but does include processes we put in place around how we use the AI models. And the question we should be asking is how can we find great human plus AI systems that are solutions to hard problems? So to me, this is a design question, and more specifically, it's a question which is going to take us in the direction of searching for optimal designs, right? So when I talk about design, I mean, how do we put a process plus the model together to design or architect our own human plus AI combination that we will then offer to the business as a candidate solution, right? How do we do that? And that is a design question. And I think that takes us to our first very short break in this webinar, which is really a poll.
Thank you, Balaji. Now I'm going to launch our second poll. So everyone, you will see a question on your screen about performance and artificial intelligence. Please choose the answer you think is best. So I'll give you all a minute to read the question and choose your answer. Oh, we're seeing some good responses coming in. I like to see this.
So Clayton, your first question was about trust. The second question is about performance, right?
Yes, that's right. Okay, I'm going to give everybody just another few seconds. If you haven't yet entered your response, please do so now. Now I'm going to end the poll and share the results so you can all see what the other attendees think about the answer to this question. And as you can see, most of you answered the same way as you did the trust question, that you think that humans taking the lead and AI playing a supporting role would perform the best. But I'm seeing a lot more responses for that second choice, AI taking the lead and humans playing a lead role. Split still about 2-to-1 on humans taking the lead, but I'm seeing more responses thinking that AI maybe could take the lead and humans could play a leading role and we would get good performance here. So I'm going to go ahead and stop sharing this poll. You can close that, that window on your screen, and Balaji will continue with his presentation.
Yeah. Thank you, Clayton. I think the only reason for this, for the results being different, is that these are clearly bots. You know, there's no chance that anyone in my class 30 minutes into my class is usually awake. So, you know, now that we know what explained the differences, I want to sort of pivot to the second half, where I promise that here we don't have solutions, but, you know, I'm going to give you a few things that will, I hope, get you thinking in a different direction in terms of how you should be thinking about, you know, what architectures you might want to explore yourself in solving your problems, right? So, you know, we said this was a search for optimal human plus AI systems in terms of coming up with designs that you might find works in practice for these non-fully online firms, where clearly the processes and human actions make a big difference. Now, stepping back, you know, if it even within the hospital setting, I think it was clear to many of us that the number of possible actions that a hospital could consider is very, very large, and this is true in general for a lot of real problems. And therefore, trying to take this option by saying, look, I'm going to come up with all possible combinations in which humans and processes and people can work together, and then systematically test them through A/B testing. This approach is often impossible because of the number of combinations being large. And so this leaves us with what I propose here as two paths. These are generally well known in both academia and I think also in industry. But I think it's important for us to revisit this when we're thinking about human AI design. So the first path is the intentional design experiment. So here you identify a set of candidate design configurations and create experiments to evaluate them. So what are candidate design configurations? Well, in the hospital readmissions case, you come up with ways in which the predictive model gets used by doctors and the operations staff at the hospital, and then come up with a series of different options, right? Path A, path B, path C, path D, and so on, where each path is a different set of outcomes in terms of how it plays out, right? So one might be keeping the patient in for an extra day. Another might be letting them go with home care. A third might be letting them go with virtual follow-up, whatever it is, right? But those are the different kinds of things we're talking about here. Come up with those configurations using your own knowledge of what you think is likely to make sense, and then systematically then test them, right? So still, I'm advocating trying to test them using some kind of controlled experimentation in different settings. This may or may not be as feasible. So this opens up, the second path, which I think is also practical. So these are what I would call as iterative design experiments, where you're not necessarily coming up with 6 different options and then having, groups of people separately go through each and then compare them at the end. But instead, you might say, I'm just going to go with my so-called best idea right now, but then iterate, right? So we launch something which is our initial configuration. The initial configuration could even be organic. So in the context of financial advisors, this could be just giving them an AI tool, a generative AI tool, and seeing what they do, right? And then that's the organic experiment. That's the initial run. But then have a systematic process by which you are constantly evaluating, tweaking, and iterating through various designs by starting from a starting point that you conveniently chose, right? So these are iterative design experiments. So my point here essentially is that I think most firms should start doing this if they're not already going in this direction, particularly as they're exploring, how do I make these AI tools work in practice? I'm going to bother you a bit for 10 minutes with something a little more abstract, but I promise you the reason for this is that I hope that there'll be a few takeaways here which are interesting, right? So I'm going to ask a seemingly very simple question that most of you already answered in the poll, which is that, is augmented intelligence, which is this human plus AI system, is this better than pure AI or humans alone, right? And I think most of you said yes. Rolling back, I think, almost 15 or so years, there was a so-called fundamental theorem of biomedical informatics, that in a paper where it was postulated that generally, if you take humans and give them information, that they would do better things than humans alone, right? So the question is, will this type of thinking translate to AI? Will the same logic apply? I think a big difference is that in the previous world, the amount of help we got in intelligence was actually bounded by our own intelligence. We designed these systems that humans were using. And today, we are still sort of designing it, but a lot of these systems now are driven by massive data. And it is quite conceivable that these systems pick up things in the data that even we as humans are not able to pick up, maybe in real time. And so we are at a point in time where it's fair to say that we have the ability to almost design these supra intelligent systems. And so the obvious thing, may not no longer hold. And the question we should be asking is, will humans plus these AI systems, will it be better than humans alone? Or in other words, other situations where it might not, maybe the humans might be detrimental, right, to the system as a whole. Or maybe the AI is detrimental to the system as a whole. And so how should we be thinking through this? Now, someone told me that no webinar is complete without some math. And that's why I have like a few slides here. But I've been working on a conjecture that I call a collective intelligence conjecture, and I want to take you through this and then point you to a few things that might be useful by looking at it from this perspective. So let me first explain what's going on here, right? So the collective intelligence conjecture is actually saying something really simple. So this is basically saying for all problems, there exists a design such that the expected value, the expected fitness or goodness of that design in a human plus AI system is actually better than the human system alone or the AI system alone, right? So if you look at what's going on down here, this is, computing the fitness of, let's pretend I only have humans, doing it, or only have AI doing it. How good would it be? The human plus AI system, has to be greater than or equal to this, right? So I'm calling this a conjecture because it basically reflects this notion that, augmented intelligence should be better than, humans or AI alone. However, when you look at it from this perspective, a lot of things get interesting, particularly because even simple notions like fitness in non-fully online settings become very complicated, right? So, for example, when you take the hospital situation into account, fitness may not be necessarily the outcomes alone, because a lot of what we end up doing might inflate costs in a very substantial manner. So we may have to think about it from a cost perspective as well. In the financial advisor point of view, fitness could be many things. Fitness could be when you provide Gen AI tools to the advisor, is the advisor able to advise clients better? Right? Better how? What do we mean by better? Right? So, is their financial performance now materially different? And how do we track that? And that often takes months or years to track, right? So that puts us back in a tight spot. How do we measure fitness? Or do we want to think about the person being able to handle more clients, right, than they used to before, and somehow hope and pray that their performance is the same? And now, so these are questions that are non-obvious, but have to be systematically thought through as well. To me, what is particularly interesting when we look at it from this perspective is that when we lay it out like this, the expected value, the expectation makes things interesting, because we sort of acknowledge that in expectation, the human plus AI system will be better than human and AI alone. But it's quite possible that on a specific case by case basis, that it may perform worse, right? So we've seen this in our real lives, right? We've seen our self-driving cars run into accidents that no human would do, right? It's possible that we may end up being in a situation where we take an action where a patient in a hospital dies, right? Because of how AI is being used. Now, it's quite possible that if AI wasn't used, that particular patient may not have died, right? But overall, right, maybe the system as a whole is going to be tremendously better, right? But on a case by case basis, we cannot guarantee that this new thing that we are building is always going to be superior, right? And that's important for us to understand, because I don't think any amount of design is going to solve that problem easily. The last part which I want to point out with this, and then I'll promise we'll go away from the math, is that when we think about this conjecture, the fitness of human plus AI systems compared to human and AI alone, and let's assume that we've explored, we've tried many design combinations, and we've figured out how good these are and how good each of these are. Suppose we find out that the best that we come up with is only the same as AI alone, right? What does that mean? To me, what that means is that then for that particular problem, you're probably better off automating, right? Because despite a lot of human AI configurations, you find that no human AI configuration is better than the AI configuration alone. And that almost sets the stage for problems that deserve automation and where we want to take the human out. And then others where we see the benefit, right? We want to engineer for that and train people and do things better. So, that's the only purpose of the math there. And like I said, I wouldn't have had that there if Suresh and Clayton didn't tell me that the webinar folks had asked for at least 3 slides of math. So the very last part, right? How do we now design these systems? This is hard. We don't have answers. The good news is there's a lot of research going on as we speak that are trying different combinations. But in general, if you ask people how we design human plus AI systems today, this is a sobering picture from the New York Times. The top are decisions made by humans. The bottom were decisions made by a machine. And as you can see, the humans and machines were going in different directions throughout. And unfortunately, this was the Lion Air plane crash that eventually, in this particular case, the machine won, right? Unfortunately. However, please remember the slide that we talked about 2 or 3 times back, because in expectation, if you talk to anyone in aviation, they would still argue that the systems in place have done much more better things than the bad things that we've seen. This is the same example as expectation versus individual case. But at the same time, I'm using this example just to show that there's a lot of opportunity for us now to think about how to design these augmented intelligence systems more systematically than we've ever done before. There are two types of work that I think are going on in research as we speak here. There's a lot of work that's doing foundational conceptual work, which is understanding the pros and cons of AI and humans fundamentally, and then using this to propose designs on how to combine the two. There's also some work, interestingly, in the area world I come from, that is looking at computational approaches and simulations to study human AI systems, because sometimes in practice, simulations are the only way we can even study these things, because it might be hard to actually create these types of experiments. At Maryland, we have this amazing person called Ben Schneiderman, who had worked on human-centered AI for a very long time. And you hear these conversations everywhere, both in industry as well as in academia right now, asking that the focus be shifted to the human, not from an empathetic sense, right? For my presentation here is that it's not necessarily from an empathetic sense, but the focus has to be centered on a human now if we want to solve these real problems using AI for these non-fully online businesses, which is my focus here, right? Now, there are some ideas, interesting ideas that have come out, and I'm in the remaining few minutes, I'll touch upon just a few, right? Again, none of this is going to be a solution architecture for you to take tomorrow and start implementing. But as I said, the goal of this webinar is to encourage thinking in this direction, to get you to start thinking about human AI design, rather than to present a solution as we know that this is the best, because honestly, we don't know yet. But here are some small bits of information that we are starting to learn, right? When should AI and human, how should we combine the two? The United States National Science and Technology Council report had some very interesting, but I think fairly straightforward heuristics on maybe how to start approaching human AI design by using these ideas here. In a recent paper a couple of years back, along with some of my colleagues, we looked at future of work in an augmented intelligence world. And the approach we took there was thinking about human skills and the foundational technology skills, and how each of these could be combined to do very micro level things like situational awareness, coordination, actions, and so on. Again, these are all emerging basic new ideas out here. I'll give you a few more pointers. Like some of this, particularly Vinton Cerf's article is quite old. It's about 10 years old, that talks about augmented intelligence. Still a great read. There is some fascinating work by Andreas Fuggener and some of his colleagues, some of our colleagues in information systems, where they have experiments that showed, and I briefly want to mention this, although I won't do justice to their paper. But this paper, where they focused on how to combine AI and humans, actually, in a sense, showed the opposite of what many of your surveys suggested. That what they ended up showing was that when the human was taking the lead and delegating the AI to AI, the system as a whole performed worse than when the AI took the lead and delegated to humans. So fascinating paper, go read. But that said, let me add a warning that applies to all of these papers, including my own, is that we don't have context-free insights yet. For a lot of these, you have to understand the exact context that it was used on, right? So in this particular paper, they had looked at image classification, where the task was to figure out what an image was, right? Was it a German Shepherd dog, or was it a tiger, and so on. And so here you had the AI doing the classifications, you had the humans doing the classifications, and they were deciding when they want to delegate to each other. But it's still fascinating that when the AI delegated, the system as a whole did better than when the humans for that specific task. If stepping back, I think what I'd like to convey here is that these sorts of insights that are coming out as a result of systematic design experiments that people are doing in various contexts. These are the things that I would encourage businesses to start thinking about right now. And as you all are using, AI plus humans and processes to do things, what kind of intentional design experiments can you design or identify before you decide to go build it and test it? Or would you rather do iterative design experiments? And how would you start with your initial configuration? And how would you evaluate, tweak, and iterate? So, some takeaways from a lot of what we've discussed in the second part. As I said, the promise here was that I hope that I would make you think about this, and hopefully in a different way than maybe you thought about it earlier. But to walk out of this thinking of AI use in business as not just, is AI good or AI bad, or should we use it or not, but to start thinking about this as a search for optimal designs, and start exploring or designing your own configurations right now. Second takeaway is, remember the math, a little bit of the math and the conjecture, and understand that there are a few very challenging things here that will take time to figure out, but are very important. You don't want to make hasty decisions on any of these. The first being evaluation. How you evaluate the fitness of a human and AI system makes a big difference, right? Oftentimes people rush into picking a metric, realizing much later, maybe a year later after deployment, that maybe the metric itself was flawed, right? So I've always recommended not going with one metric, but having a set of different metrics, but take your time to ensure that the metrics are not just short term, but also long term. Because there are some things that may happen in the short term that may disappear in the long term. And so having a set of metrics and also having the set of metrics capture outcomes in both the short term and long term is important. And so this needs to be carefully thought through. When looking at the conjecture, I pointed out that the augmented intelligence conjecture, if we take that as a given, is being posited in expectation, right? So that means that on average, we expect these augmented intelligence systems to do better, which is probably the case in most situations we've seen. But on a case-by-case basis, that may not be the case, right? And so it's important. So this is what I've called here as superiority in expectation versus universal dominance, right? Personally, I think universal dominance is likely impossible to achieve. And so what that means is to always prove that the AI system will never do harm, right? Personally, I think it's likely impossible to achieve, but I'm open if any of you have ideas. The last point that I would stress here with respect to the conjecture is that if you remember, I said that, in an ideal case, we want to take all possible configurations, come up with all possible designs and test it. But then we know that we cannot, right? We can only in real life and practice, particularly in any business scenario, we only have a handful of design configurations we can test. So this will always have to be a limitation of any human AI design, that maybe we have not optimized it. Maybe this is not the best simply because it's impossible to list all and test all of them. The very last point here, which is really my focus when I have been particularly in some of my conversations with companies recently, is on governance, right? So what does all this mean for how AI governance should be handled within regular firms, right? What are some of the issues that they need to be that you need to be thinking about front and center, and how should you put together a process to make sure that you're watching for all the things that you should be watching for, while making sure that you're not focusing only on the risks, that you're also focusing on a lot of the benefits, right? So sometimes what I've seen is that there's a big focus toward the benefits, ignoring the risk, and that's bad. And I've also seen the opposite, where firms, worry a lot, and they leave a lot of good things on the table, right? So with good governance, I think in this context, it's possible to have your cake and eat it too. So with that, I will hand it over to Clayton, who is going to, I think, take us to The next
Thank
part.
you, Balaji. Yes, yes. This has been a great presentation, and I want to thank you for all this wonderful information. And I want to take this opportunity to talk about an AI event that we have coming up here at the Smith School on January 23rd. Balaji is hosting the AI Symposium on Design and Governance, and you are all welcome to attend. I will share a link to the registration page here in the chat, so you can click on that link, learn more, and of course, register for the event if you'd like to come. And we'd also like to take your questions after this. So I have 2 questions from our audience. I'd love to see more, so please enter your questions in the chat, and we can answer your questions as they come in. But Suresh, I know you had a question that you really wanted to ask Balaji. Why don't you kick us off?
Thank you, Clayton, and Balaji, thank you for a wonderful presentation. I really like the way you put things in a structure, things that we've all been thinking about, but having that structure in place certainly helps. Given our audience, I'm sure everyone's been wondering this, and given your interactions with industry, when it comes to human AI design, is this what businesses are thinking about? Are they doing this? And to your point around context, are there certain domains, certain industries where this is where the adoption of this is higher, and are there other places where it isn't as much?
So I would think, again, one of the things I've learned is that the world is so sophisticated, and businesses, are in many cases way ahead of where we sometimes think they are. That I don't want to say that no, this is not happening, but I'll say that a lot of the firms I talk to, that I have talked to, are not doing this yet, but understand what this is, asking them to think about. Now, why not? Because I think a lot of the initial use cases that we are seeing, even in generative AI, is the low-hanging fruit. These are configurations of, where people think that, hey, just making this available is going to create good things, right? So simple things like, for instance, email generation, right? Having a starting point for email so that sales agents don't take as much time typing emails. So this is quote unquote a no-brainer for many of them. And so some of their initial things they're trying are the low-hanging fruit where they don't necessarily need to experiment. But I think they are aware that if they want to go down the other path, that this is a direction that they have to do. The challenge, I think, is that a lot of systems that, the online firms can track things, can track experiments, can track interventions automatically. The kinds of things we're talking about, human decisions, process things, these are harder to track automatically in today's systems, the way they are designed. And I think that's going to create an interesting opportunity and a challenge as well.
Thanks.
That was a great question, and I'm going to move on to our first question from our attendee. Someone asked about what I think is Neuralink, one of the projects that Elon Musk is working on, where he's working on chips that go in brains, like human brains. And what do you think about this, Balaji? Would this be an example of AI, like augmented AI, or would you say this is something different, something else?
It is definitely augmented, because I think we have, but it's different from the kinds of things I've been talking about here. But this is giving humans potentially new sensors, new information, so that humans take their own actions better, right? So I think the focus here is on individual human level decision making by giving you maybe memory, processing power that might enhance what the brain is capable of. One thing I've learned is never bet against Elon Musk, right? So he's definitely a phenomenal thought leader, comes up with great ideas, and I'm curious to see how it will pan out.
Thank you, and thank you also for our attendee for that great question. Our second question is about humans taking the lead. So our attendee writes, would it be fair to assume that humans taking the lead is most useful in providing high quality data to AI systems, but not for other tasks?
This is a fantastic question, because I think anyone who's like, if you followed some of the recent New York Times, OpenAI copyright lawsuit, and some of the discussions that are coming out around that, is that one of the interesting themes that are coming out is how much human data is needed to make AI work well, right? So if humans were not generating quote unquote organic data, would AI have the kind of data it needs to train on? And how do we have an optimal balance of the two? So humans taking the lead, I think to the questioner's point, in terms of creating data is now quite well recognized, and that's an excellent point. But in terms of the human AI collaboration settings, it is, how much of the decision making is, let's say that we want to put in the hands of the doctor, where the doctor uses, let's say, output of a predictive model, and then the doctor does their thing, versus the doctor provides their input, and then behind the scenes, the predictive model makes some decisions, right? And that's the distinction, I think, where most of us want to say we want the humans in charge. And I think that's natural to say, but I would, encourage everyone to have this open perspective and not assume that that's always going to create better outcomes. We might pick a human-led configuration from a values perspective, right? To say that that's our values, this is how we want to design, and I can certainly see the merits of doing that. But I don't think we should jump into the human taking the lead option in all contexts from a fitness perspective, right? In other words, I don't think we should be assuming that if you give humans the lead, that they will know how to use some of these systems so that outcomes are going to be superior, right? So when you say outcomes, we mean the patient outcomes. We mean whether your client's financial portfolio does better because of the advice. Those are all questions I think that still need to be determined. And I feel that, and I think most people might agree with me, that I think that the answers may be very context dependent, that we're not going to have an answer that's true for all settings.
All right, those are all the questions we've received from our attendees. And we just have 3 minutes left. So I don't think we have any time for more questions. So I think we'll just take this time to mention that we do have an online course on this topic. So any of you who have attended this session and you're interested in learning more, I'm going to send out an email to you all with a link to this course and some information about it. I'm also going to share a link to the course in the chat, and you can see a link there on your screen. This course gives you a lot of background information, and it will help you understand more about where machine learning and artificial intelligence are today and where they're going, how it might affect your industry. So if you're interested in that topic, feel free to enroll in that course and learn more. Now, today's presentation was recorded, so if you missed part of it or you'd like to share it with others, I will also email a link to the recording as soon as it's ready. Give us a few days to do that. I will also post that link on our LinkedIn page. So if you haven't yet followed us on LinkedIn, head over there and follow UMD Smith Executive Education, and you'll be in the loop for everything we're doing with AI at Smith. So again, thank you all for attending today. Thank you, our great professors, for this wonderful presentation and this discussion. It was great to have you all with us, and we look forward to seeing you at the next event.